Welcome to the Topic Blast series Day 2 walkthrough. Today's topic is simultaneous equations, so have your booklet ready so that we can go through the answers together. So in this first question, we've got a pair of simultaneous equations, and looking here at these two middle values, we'll see that both of those four y's are both the same thing. So actually the first step, what we've usually seen from a simultaneous equation, is done. All we have to do then is just subtract these two from each other. Now I'm going to subtract upwards because I don't want to end up with negative numbers. So I'm going to do 5x take away 2x to give me 3x. 4x take away 4y take away 4y is 0, so they're gone. And then 19 take away 10 is 9. If I divide both of those by 3, I end up with x equals 3. So I found my value for x. Now in simultaneous equations, we're trying to find both our x and our y value. So the second step we're going to do is we're going to substitute our x value into one of our two equations. You can pick either equation, but I'm going to pick the first one. So we've got 2 times 3 plus 4y equals 10. And then all we do is solve this equation. So 2 times 3 is 6 plus 4y equals 10. Subtracting 6 from both sides gives me 4y is equal to 4. And then finally dividing both sides by 4 gives me an answer of y equals 1. So my solution to that question is that x equals 3 and y equals 1. And we should always end up with a value for x and a value for y. Our second question, very similar to the first one, has matching terms in the middle. However, in this case, one of them is a positive and one of them is a negative. That just makes a very simple change there. So again, we're looking at our y values. Because we're subtracting those, to make these into 0, we're going to do 2y take away 2y. So what we're actually doing with these two lines is we're adding them together. So then we'll do 3x plus 2x is 5x. 2y plus negative 2y is 0, so that one cancels out. And then 4 plus 6 is 10. We divide both of those by 5, and we've got our first one of x equals 2. Again, taking that x equals 2, we're going to substitute that back in. Again, I'll pick the first line. Again, you can pick the second one if you wish. I like to use the one that doesn't have any negative numbers in there. It just makes it a little bit easier for you. So substituting that in, 3 times 2 plus 2y equals 4. And now just solve that equation again. 6 plus 2y equals 4. Subtract 6 from both sides. We get 2y equals minus 2. And then finally, to find 1y, we just divide both sides by 2. And we get y equals negative 1. So our solutions to these simultaneous equations is that x equals 2 and y equals minus 1. Now we didn't do this in the last question, but we can, to check our answer, we can sub those two into the second equation, the one we haven't used yet. So if we do that, we get 2 times 2 minus 2 times negative 1 equals 6. Now 2 times 2 is 4. Minus 2 times minus 1 is positive 2. And we can see that 4 plus 2 is 6. So we know that our answer is correct. So that's a way we can check our answer. We can just substitute our answer for x and our answer for y into the other equation that we hadn't used. So in this case, we use the second one. So we substitute that in and we see that 4 plus 2 does give 6. So we know our answer is correct. Now our third question is slightly different. You'll see that our x's don't match our values and our y's don't have the same coefficients. So the numbers before our x's and y's aren't the same. But in this case, what we can see, if we look at our y's again, we can see that by simply multiplying the second equation by 3, it gives us the two y's to be the same value. So we're going to rewrite our first equation exactly the same way that it was. So 3x plus 6y equals 15. And then our second equation we've multiplied by 3, so we get 15x plus 6y equals 13 times 3, which is 39. Now, again, we're now in that situation where we've got our 6y's in the middle. Both of them are positive, so again, we're going to subtract those two equations. Our bigger 15's on the bottom, so again, we're going to subtract upwards. 15 take away 3 is 12x. And then 39 take away 15 is 24. Dividing both of those by 12 allows us to get an answer of x equals 2. And now we're back to the same step again. We found our x value, we then substitute that into one of our two equations. Let's do the second one this time just to be a bit different. 5 times 2 plus 2y equals 13. 5 times 2 is 10 plus 2y equals 13. Subtracting 10 from both sides of our equation gives us 2y equals 3. So y equals 3 over 2. Now you can leave that as an improper fraction, or if you prefer, you can convert it to a decimal of 1.5. Again, to check our answers, we substitute into our second equation, so let's sub it back into this first equation. We've got 3 times 2 plus 6 times 3 over 2 equals 15. 3 times 2 is 6 plus 6 times 3 over 2, well 6 divided by the bottom, so 6 divided by 2 is 3. 3 times 3 is 9. And we can see that 15 is 6 plus 9. So 6 plus 9 is 15, so we know that we're correct. Again, we don't need to do this. This is just our method of checking our answer. Okay, as I said, we don't need to do that, but it's a good thing to do so that we know, okay, I've definitely got my answer correct. Now in this question, similar to the previous one, none of our variables, so our x's don't have the same number before them, same coefficient, and our y's don't have the same variable. Again, the last three questions we've made the y's the same. In this case, it's actually easier if we make the x's the same. Now you might not see that immediately, and that's fine, but we're going to make the x's the same to show that it works with either. Now, to make these numbers the same, I want to make both of them into 6, because 6 is the lowest common multiple. So I'm going to multiply the first line by 2, and I'm going to multiply the second line by 3. So my new equations are 6x plus 4y equals 8, and 6x minus 15y is equal to, now 29 times 3, you might need to do that over on the side. Let's do 29 times 3. Well, 3 times 9 is 27, carry your 2, 3 times 2 is 6, plus 2 is 8, so that's 87. So because it was minus 29, that's now minus 87. Now looking at our x's this time, they're both positive 6x, so we're going to subtract these two lines from each other, okay, because we have positive 6's. Okay, so now we've got 4y take away negative 15y. So 4y take away 15y actually means we're just going to add these two numbers. So 4 plus 15 is 19y, because subtracting a negative is the same as adding. And then the same thing here, 8, again, that's a minus 87, but because we're subtracting that, it's the same as adding them, and that gives us 95. Okay, now to finish this, divide them both by 19. And you might need to check this, but we can see that 95 divided by 19 should give us 5. So y is 5 in this case. Now if you can't do that in your head, just on the side, just do 19 plus 19, gives you 38. Add another 19, gives you 57. And another 19 will give you 76. And another 19 will give you 95. And you can see that's 1, 2, 3, 4, 5 19s. That's why it's 5. Now, then substituting, I'll just do it on the other side this time. I'm going to substitute into my first line so that I'm not using the negatives again. Now remember this time I found y, so I have 3x plus 2 times 5 equals 4. 3x, 2 times 5 is 10, so plus 10 equals 4. Subtract 10 from both sides. You get 3x equals negative 6. And again, dividing both sides by 3, we get x equals negative 2. Okay. Now if we want to do our check, we can check it here at the bottom. Let's do 2 times negative 2 minus 5 times 5 equals minus 29. Well, 2 times negative 2 is negative 4. Negative 5 times 5 is negative 25. And negative 4 take away 25 is in fact negative 29. So we know again we're correct. Now question 5 is a little bit different to the previous questions we've seen. What you'll notice is that our two equations look slightly different to the ones before. Now there's a hint at the bottom that tells us to rearrange first, because we want it in the form where we have our x, our y equals our constant or our number. So our first equation is okay. Our second equation though, we want to take this 3y and we want to bring it over to the other side. Now when we bring it over to the other side, all that happens is it changes from positive 3y to negative 3y. And then we've got our equals and our negative 1. so it balances out well. And now we're back in the same position. We've got an x, a y, and a whole number, and an x and a y and a constant value. And what we're going to do is we're going to make one of them the same. I'm going to make my x's the same again, so I'm going to multiply the second line by 6. So you can see there's two levels here of adjusting our equations before we can even start doing the method we had before, which is sometimes where students have difficulties. But we want to get it back into that same format that we're familiar with. Now we can do this very easily. We've got our 6x and 6x again. Because they're both positive, we're going to subtract those. So that gives us 0. And then remember, negative y, so that's 1. Negative 1, take away negative 18. That's the same thing as saying negative 1 plus 18. That gives me 17y. And then 11, take away negative 6 is 17. Dividing both of those by 17 gives us y equals 1. Now we substitute that in. Now I'm going to substitute into my second one, and what you'll see here is that it's actually a little bit easier to do it with this second equation, okay? Because actually it doesn't involve any rearranging. So 3 times 1 is 3, take away 1, so x gives me 2. So now we've got x equals 2 and y equals 1. Now we can just do our check nice and quickly. And again, you don't have to write down your check. You can do this part mentally, but it's a good habit to get into to always check your answer to make sure you've got it correct. And as we see, 12 take away 1 is 11, so we're all good. For this final question, we need to be careful. Now, I've put the hint of rearrange first there, but what you need to look at is you might make the mistake and think, actually, they are already rearranged, but if you look carefully, the x and y are the opposite way around in each of these. So if we rearranged what we had before, we're going to put our x's first, so 2x plus 5y equals 11. Now notice our 5y or 2x don't change because they've not moved across the equal sign. They're just the opposite side. And then we've got 3x plus 6y is equal to 12. And now we're back to what we had before. Again, I'll make the x the same because they're slightly smaller numbers. So multiply by 3 and multiply by 2 gives us 6x plus 15y equals 33. And 6x plus 12y equals 24. Again, looking at the x's that we've made the same, they're both addition, so we're going to take those away from each other. They're both positive numbers, so we take those away. 15 take away 12 is 3y, and 33 take away 24 is 9. Dividing both sides by 3 gives us an answer of y equals 3. To finish off this final question, we're going to substitute it back in. Again, we've worked out y, so if we sub it into our first equation, 5 times 3, remember our y is our first term in this case, plus 2x equals 11. That means 15 plus 2x is equal to 11. Subtract 15 from both sides, and you get 2x equals negative 4. Dividing both sides by 2, x equals negative 2. And then finally, to check our final question, we'll sub this into the other equation, so the second one. 3 times x, which is negative 2, plus 6 times y, which is 3, gives us 12. Well, 3 times negative 2 is negative 6. 6 times 3 is 18, equals 12. And then if we do minus 6 plus 18, that is 12, so we know we're correct. Thanks for watching the video. I hope you found it useful, and I'll see you tomorrow for the next video.